Okay, so thank you for today. I'm David Rhodes, and today's presentation is basically on pressure reducing valves, or more commonly referred to as PRVs, the content of which has been certified by CIBSE. So if at the end of the session or following on, if you can send through email addresses or a central point and people's names, we'll make sure we get a little certificate sort of sent out so it's all done officially, if you don't mind. Yeah. And you can do that sort of through Scott, and we'll sort that out. Okay. Right, let's get straight into it. So I say I'm David Rhodes. I'm the technical manager for Albion Valves. So we are allowed to say a little bit about Albion as part of the presentation. Not much, but a little bit. So Albion Valves really been going for over 40 years now. Operating what I would call a little bit underneath the parapet from sort of your mainstream sort of valve manufacturers, but we've been heavily involved industrial to begin with in the beginning, and then probably more recently in that 40-year span, sort of moving into more building services as more and more demand came upon us to supply various types of products. So yeah, as any business, we have sort of core competences that we like to promote. So, you know, quality, service, delivery and choice. But to be fair, you know, we do have a wide portfolio of products, and it's really based upon demand from our customers rather than us trying to sell and promote anymore. You know, people come and ask us, make requests, etc. So we're constantly adding to that range. Excuse me a second. But the main thing from our point of view is availability and that delivery, if you like. That's really where we come from. We have two main facilities in the UK, one based in Barnsley in South Yorkshire, and the other one in the Middle East. And they really do, we do pride ourselves in, if you like, on our stock holding, so that people can ring up and quite regularly do want, you know, say, you know, common standard items, say butterfly valves, and we'll have them on stock available. Particularly when you start getting into the larger sizes, a lot of our competitors don't stock them, whereas we do. We'll typically stock up to 16 inches quite readily available on site. Okay. So now I've sort of introduced a little bit about sort of Albion, a little bit of focus on today's sort of presentation. So there's a little bit of an overview on pressure reducing valves. So we're going to take a look at, you know, each of those subjects, their general functions, understanding how they work, little bit on the performance standards, but mainly around selection and sizing. That's really where the sort of today's message really wants to come from. And then more laterally in the presentation, we'll move on to a different kind of pressure reducing valve that comes out, which is the pilot operated pressure reducing valves. A little less common. People really sort of tend to shy away from them because they don't understand them, but it's a very common to a degree, less known but quite common pressure reducer valve. Okay, general function. Well, when you start talking about pressure control valves, everyone thinks of things like pressure relief valves or pressure safety valves, and they basically lie there dormant or inactive until it reaches a set pressure or a signal or something triggers it to actually activate. Now, pressure reducing valves are in effect, although they're in the same family of valves, are actually the opposite of that. They're constantly in operation, reacting to the upstream pressure that's supplied to the valve. They're constantly operating. Okay, and again, you know, I can't sort of stress too much in the different types of valves. They really are sort of selected, or the mechanisms are selected internally against the media of which they're going to be selected or used on. Okay, and it's really important to verify that if you like, the selected valve is suitable for that media. Okay, a number of them will handle different types, but you can sort of see there from the example, you know, some of them are suitable for one type of media, others are suitable for another. Quite often, a lot of people will turn around and just say, "Oh yeah, I've got a high pressure, I want a low pressure," and they'll just put a pressure reducing valve in there and think it can handle everything, and they can't. and we'll explore a little bit into that today. So for the purposes of today's presentation, I'm going to sort of simplify that down. I'm going to use it more focused on, if you like, your potable waters or your low temperature hot waters and cold water, typically around sort of -10 to +85, that sort of range, and it just makes it easier for the presentation. Okay, so you'll probably be more familiar than me in the areas of why the need to reduce pressure. Well, typically there's three main reasons, really. We do talk about conservation when we're talking about pressure, strangely enough. So I'll give you an example of that. If you have a tap outlet that's sort of open for, say, 5 minutes, kitchen sink, for example, and the pressure there is around about 5 bar, it's going to pass around about 40 gallons of water, yeah, in that 5 minute time. You reduce that to 3 bar, it'll only pass around about sort of 25 to 30 gallons and give you a significant saving in that water. So conservation does come into it. You've also got the aspects of some of the regulation and the plumbing codes that come in there, where the guidance is, we have to provide a set pressure to a set point within a building or to the junction where you're then going into a building. So there's various legislations and regulations and guidance, I suppose, in around the pressures of where they're supposed to be and plumbing codes that go around that. And last but not least, it is or can be classed as a safety valve. Pipework systems typically PN16, PN25 or PN14 in a high rise, and you literally can use the pressure reducing valve to make sure that either the pipework system or the terminal unit downstream, whether that happens to be a tap, a shower, a washing machine, whatever it happens to be, is protected by the pressure that it's seen. So it can be classed in that context as a safety valve. Okay, they tend to be, if you like, the sort of three contexts which is done. Okay, so how do they work? Well, they're really simple in a lot of the cases. In that, the upstream pressure comes into the valve and is acting or forcing itself against the seat or diaphragm, typically in most of the sort of modern type pressure reducing valve, it forces away against the seat there. And it's that spring force that then is applied on the other side of the diaphragm, forcing the diaphragm closed. It's one fighting the other that in effect gives you the pressure reduction across the valves to the downstream. Now, so remember, every valve has a pressure drop anyway. So by adding to the pressure forces or reducing the orifices that go through the valve is a way of reducing that pressure at the outlet side. So that's basically how they work. All you're really doing is forcing the water pressure against the spring pressure within the valve. Really simple. Yeah. Now, as I say, the more modern types of pressure reducing valves are designed using this spring-loaded diaphragm arrangement. Now, fundamentally, there are sort of two ways of controlling that downstream pressure. Seen on the left, the more common ones that people are probably more familiar with, which are the direct acting, and then you've got the version on the right, which is pilot operated. Still works in the same way where the force is operating against the spring-loaded diaphragm. Okay, but in this instance, we're using a pilot signal to trigger it. But I'll explain a little bit more about how they work further on in the presentation, because they do take a bit more understanding. But direct acting, most people are familiar with those. So direct acting sort of type pressure reducer valves, typically up to and about 4 inches in diameter, found in a range of applications, including OEMs, buildings, building structures, residential, commercial, that sort of thing. And so if we consider control of the valve, what we tend to do is we talk about things like upstream pressure or the input or the line pressure is what's coming to the valve, and then we'll talk about things like downstream pressure requirements, etc. And they're the sort of terminologies we use. But typically, income and upstream pressure of 9 bar with a downstream set pressure of say 6. Okay, that's the sort of terminology that's used. Now, in practice, that's never the case. It's never fixed at 9 bar. It will fluctuate up and down depending on the supply situation. And it's the same with the output pressure. If you set that at, say, in this case, you set it at 6 bar, it will fluctuate. It will go to 6.1, 6.2, 5.8, 5.7, back to 6. It fluctuates. Yeah. And it's normally that downstream fluctuation is the adjustment of the valve or the speed of the valve to react to the upstream fluctuations. So the more constant your upstream pressure, the more, should we say, repeatable, or if you like, less deviation is the downstream pressure. Now, typically, the terminology we use for those fluctuations are droop. We use a term called proportional band or offset. And basically, it's that deviation from the set point that as that sort of goes through, if you like, the valve. Now, it does increase, that amount of fluctuation does increase with the diameter of the valve. If you take it as a percentage, and which is the best way, if you sort of take the smaller valves, they'll deviate typically 5 to sort of 10%. When you start getting up to 3-4 inches, they'll go upwards of that. They'll be, and I've got a few sort of figures in there, but they'll go upwards of 20% on that offset or deviation, particularly when you're in and around that 4-inch. So just be mindful, there's a certain accuracy required or repeatability in the valve itself, depending on what the upstream situation is. Okay. Now, pilot operated reducing valves, these are typically used where increased flow rates are required. Now, it might sound a bit daft because, okay, we're going up to sort of flying sizes and that sort of thing. But these sorts of valves are the pilot operated start around 2-inch and will go up to like 12, 14, 16 inches. So you can see there's an overlap between the 2 to 4-inch range, and that's really because of that accuracy. When you start getting beyond 2 inches in a standard direct acting, that amount of repeatability or offset, proportional offset, droop, whatever term you want to use, comes into quite a bit of effect. And when you start talking those bigger sizes, it's really about, it's not so much about, we talk percentages, oh yeah, it's 10% out. It then relating that to the volume of water. So if you've got a particular process plant with a particular requirement, you have to make sure you work that out and decide which valve you're going to select from. Okay. The pilot valves are a lot more accurate than the main valve, as you sort of expect here. And that's basically because it's a PRV in its own right, used for the signal. So what you're doing is you're setting the switching or capability of that valve by the pilot valve. So you're setting the reaction of a large volume of water, and you're setting that over a small volume of water. And that, so if you like, magnifies itself out. And that's what makes this type more accurate. As you'd expect with manufactured products, there's a number of performance standards that cover. Typically, sort of UK is that 1567. And as you'd expect, it lists, various materials, particularly when you're talking about potable waters, etc. There are also things like general design requirements on its capability to react to pressures and those sorts of things. The main bit in there I'd like to sort of highlight is it also has to pass some cyclic tests, which I think is around 200,000 cycles. So if your various manufacturers will come in like we do, and we try and sell the product. But one of the things in there is that if it's to that standard, you're sure that it's a reliable product because it's passed 200,000 cycles under a set test condition that has to be verified and approved to that to be able to gain that standard recognition. So bit of an important part. Again, and it coming later, sort of because it's a pressure valve in a system as such. It does have to sort of be requirements, sort of pressure equipment safety regulations. And the one that people don't really publicise, but I will raise this, is that there's also an acoustic performance required with these type of valves. Mainly because the example I'll use will be like an apartment block. You don't want these valves rattling away at 2 o'clock in the morning just because someone in the next apartment's decided to turn the water on. you know, so there is an acoustic requirement for these as well. As I mentioned, sort of, you know, being mindful that it is part in a system, so there are sort of pressure equipment directives and PSSR that require, and if you like, the CE marking or the UK CE that didn't quite happen, but was supposed to and still might do. So again, all I'm trying to say is that there are various compliance standards. So when you're selecting a valve or someone's offering you the valve, just double check and make sure they've got the relevant sort of approvals and certification in place. It's always good practice, and that way you know you're getting a reliable product that will perform. From a maintenance point of view, and it's a question you sort of get asked relatively often with pressure reducing valves. You know, people will turn around and say, okay, we've got a maintenance function in the building, and you know, we want to maintain this valves on a schedule. My response will really be, there's that much variation depending in, and we're just talking, if you like, your sort of LTHW and your potable waters here, but there's so much variation in contaminants that might be in the water or solid particulates, etc., that all of those things and the velocity of the water itself can wear some of the components within the valve, whether that's the seat itself or whether it's the diaphragm itself. So typically these valves will last anywhere between 3 and 15 years. That's a typical sort of lifespan of the valve. So from a maintenance point of view, what I tend to respond with is, don't have a preset maintenance, but monitor the downstream pressure. As you start to see that downstream pressure alter or move from its set position, it's at that point in time that you want to consider some form of maintenance. So whether that's replacing the internal mechanism or whether it's replacing the valve complete. Okay? Monitoring rather than sort of the direct maintenance. So a little bit sort of to summarize, direct operated valves used when loads or flow rates are relatively small, and you see that because it's sort of 1/2 inch to 4 inches, and where the downstream variances are accepted. You put a 1/2 inch valve underneath a bath, no one cares if it's sort of 10% out. No one really bothers, you know. You have a 12 inch valve and you're 10% out. People start panicking because of the sheer volume of water, and that's why, if you like, pilot operated valves generally intended for the larger load applications, and they can respond a lot more quickly to those variations, and we'll go into that a bit further on. Okay. So,
good question.
Yes.
When you're in a situation where you need to be more restrictive in terms of the control, first of all, PRVs are the control valves. Can you use them for process control, or are they just, because the way you describe it now, it's more like it's what goes in is what comes out.
No, typically the definition of a control valve will be one that you can, if you like, apply an actuator and apply a set signal to it. These are more of an automatic valve. So you'll have an upstream pressure within the system. And let's just say it's a riser going out on various floors to a series of apartments. It's an easy way. So you'll have your pump set to get the water to the top of the building, but the floor at the bottom obviously will have a lot more pressure than those at the top. So you need to turn down the pressure in that water supply to that floor. So typically what you'll do is you'll say, well, it might be receiving 16 bar or 12 bar straight out of the pump room, and you want to get it to sort of 3 bar to feeding out out on those apartments. So it's automatic in that once you set it, unless somebody goes and adjusts it again, it will stay at that preset, if you like, that set condition of 3 bar. It's not, as we would class normally a control valve, where, if you like, we could say apply a voltage to and alter that setting. They're literally, if you like, an automatic valve in that once it's set, it will stay set.
It's just a rough and tumble, just stays there and just limits the volume flow.
Yeah. So, okay. Anyone? All right. Please feel free. Okay. Quite often, people will put on a drawing, I need a pressure reducing valve there. And they go, great. And there's very little consideration taken to that. Now, we can use the example I used then, and we'll come into that. But a bit like the dynamic valves and like control valves in a way, they need to be selected and sized for that application. It's no good just saying, oh yeah, pressure reducer valve, and someone else will take care of it. Yeah, it needs to be sort of selected.
One more. PRV, pressure relief reducing valve, or pressure relief.
These are pressure reducing valves. Okay, and if you like, as I say, you know, from pump set, you might have 16 bar coming out and you want to reduce out onto a floor. Pressure relief valve is more, it is actually different from a safety valve. So that was the wrong terminology we're going to use it. But basically, a pressure relief valve is more about maintaining the system pressure within, say, a system by removing the overpressure condition. So if you have pipe work at 16 bar, but my pump set can go higher for whatever reason, but I need to maintain it at 16, you can set the pressure relief valve typically 10%. So 1.6 bar over the 16. And at that 10% over, it'll open up, okay? It'll release that overpressure condition. It'll then reseat around about 10% lower than the 16, so around about those sorts of figures. So in that way, you're maintaining that 16 bar. On this, what you're doing is saying, I've got 16 bar to this side of me, I need 6 bar to that side of me.
I need to appreciate PRV, both of them.
Yeah, it's just a terminology. So you have pressure relief and pressure regulating, and then to be fair, you've got pressure safety valves as well, and they're very, very similar to a pressure relief valve, but a pressure safety valve has a lot. It operates differently in that, whereas I explained the pressure relief valve sort of maintains the or reduces the overpressure, but maintains the system. So you might put that, for example, on the pipe work. Let's use that as an example. A pressure safety valve, you'll put that onto the boiler vessel, typically, or the reservoir vessel, because when that reaches its overset position, which is less than 10%, it's about 3% from memory, it literally pops, opens up, and exhausts as much as that overpressure as possible. So the difference again.
Mm-hmm.
Yeah. That, yeah?
Yeah.
Comfortable? Okay, so so pressure reducing valves as such, okay. When people are selecting them, well, again, you know, you're looking for a valve, and typically it's based on the flow and pressure requirements that you're looking for. And you know, most manufacturers produce charts, various charts of performance to reference those against. So again, because I said sort of there's a reduction across the valve anyway, that's normally accounted for in the likes of these sorts of charts. But basically what you're looking to do is select a valve, particularly if it's, I'll say building services, so it's more in like an installation where there's domestic type applications, I'll put it, but also commercial. You really want to have a velocity between 1 and 2 meters per second across the valve. You start going any more than that, you'll start to run the risk of noise, particularly caused by cavitation and wear jetting across the seat. So you really want to keep that velocity across the valve between 1 and 2 meters a second. So again, referring to this sort of chart. We also, like a whole host of manufacturers, we produce cavitation charts, because again, that cavitation and formation of bubbles can cause a noise. So again, and whereas the other one was about flow and pressure, cavitation now is more about the step down ratio between your upstream and downstream pressure. A lot of manufacturers and ourselves, you'll pick up a data sheet and it'll say maximum 16 bar, and it'll go to 0.5 to say 10 bar. And you think, oh, that's great, 16 to 0.5. No, all it's doing is it's saying that's the extreme of what it is. You have to look at the cavitation chart to say, well, what's within that range as a step down ratio between my upstream pressure and the downstream pressure requirement that I've got. Now, a good rule of thumb is round about 3 to 1. You don't want to be going any more than that. Now we, like some manufacturers, we will have, I think there's one in our range that's actually only 2.5 to 1. Okay, but again, you can sort of pick that up in data. We do have others that are above that. Okay, but I always, a little bit old school, 3 to 1, and I know I'm going to be safe from that sort of step down ratio. Okay, so we've got the sort of pressure and velocity charts, we've got cavitation charts, and then for all those people a little bit more like me, you can actually calculate it. Okay, so there is a standard calculation you can use. I've put an example up there where sort of suggest I've got flow volume, I've got a given sort of step down pressure that I'm doing in there, and basically by the calculation, I'm looking for a PRV that basically got a KVS around about 26 meters cube per hour, and that's what I'm looking for. So, as I sort of said earlier, in that, hang on, nope, go back. Sorry, as I said earlier. That's what I was looking for, the lines on the chart. What happens is you're looking for between that 1 and 2 meters per second as a velocity. I calculated it out at 26 meters cube per hour. And what I've done, you always go the next one up. Okay. And you can see there, 29 meters cube per hour, DN80, that's the valve I'm going to select. Now, I could have gone for the DM100, highlighted it with the yellow box at 28.3. It's the next one above 26. But again, it's at the extreme of that 1 to 2 meters per second to get the valves, to help it with the longevity, to help it work more, correctly, more accurately. The more near the sensor you can get that, the better. If there wasn't one there, then I'd be quite happy picking the one with the yellow box at sort of, 28.3. But because I had one available to me, I would pick that.
What do you mean by the more near the centre? Do you mean the more near?
More in the middle of the, yeah, you see the velocities, it's sort of
yeah.
between 1 and 2. I was sort of picking it around about that middle range there. Yeah, and all that means is sort of, if you like, when the valve's operating, that velocity actually across the seat is around about that middle of the range.
Yeah.
Because what you don't want to do is pick one that's too big, so that the valve is always operating like down its lower position. Because again, you'll get jetting across the seat and you get more wear on the top of it. But if you have one that's too small and it's wide open, it's always trying to fight itself and acting against that spring pressure. So ideally, you want it as close to the middle as possible.
But what's the price difference between D80 and D100?
You have to ask him.
It could be as much as 25% dearer.
Yeah.
I mean, actually, the one that Dave picked would have been a cheap one.
Yeah.
So the one that Dave said there, green, being a DN80, is actually probably between 20 and 15% cheaper than the DN100.
Typically, the smaller,
So
typically the smaller sizes are going to be cheaper. But depending on which valve you pick, we have some of these, direct technical from standard brass to, to your bronzes. So, price varies dramatically, really, depending on which valve. So, yeah, but normally, if you can get away with a smaller one, they are cheaper. Normally. Don't tell him that, though. Okay. So, yeah, basically, when we're little thing I sort of touched on earlier is that bit about droop and proportional offset. It's something we sort of touched on earlier, and really, if you really get into it, there are 3 factors that will affect the levels of that proportional offset and droop. 3 factors tend to be sort of things like stroke length, the diameter of the diaphragm within the valve, and the bits that you'll never find out, because we like to keep it all secret, and so do all the manufacturers, is actually the spring strength itself. If you have a lighter spring strength, the better the valve, because it's more sensitive to those variations. So if you have it too hard, it never sort of adjust itself to those. So there are bits in manufacturers that make certain valves perform slightly better than others. But the main thing really is, sort of going back, it is really about, if it's to a standard, if it's to that recognised standard, you're going to get a valve that's reliable but will perform.
Is the spring exposed to the media?
Sorry?
Is the spring exposed to the media?
It can be at times. Yeah. I'll explain this. I'll explain a little bit later. But yes. Okay.
About 10 minutes left, did you say? About 10 minutes.
15 minutes left.
15 minutes.
Okay. I'll try and rush through this quickly. But so as I said earlier, typically direct acted 10 to 30% for that proportional offset or droop. Pilot operated more than sort of 5 to 10. Typically, the direct operated are really good for like single outlets, those sorts of applications. Pilot operated, you're going to see more in the plant room, controlling that pressure, feeding out to multiple units. Okay, so I rush through installation methods. Okay, a little bit like control valves, they do require, or they do work better when they're subject to or not subjected to turbulent flow. So ideally, you want at least 5 times the diameter beforehand, 2 diameters after. If you just directly after the pump set, you want about 10 diameters before to relieve that. But that's typically an example of what you would see as a single application where you're looking for the turn down ratio around about 3 to 1, as I say, or less. Okay. You can, if your step down ratio is too great, put them in series. What I would say is that unlike the picture, they don't have to be the same valve. You can have different size valves, different types of valves. And the benefit of this type of installation, although it helps to achieve your step down ratio, is that the pressure coming out from the second valve or the flow is a lot more consistent, because that deviation and the, if you like, the variation of droop offset to that upstream variation is evened out a lot better. So if you've got a system that's got a lot of variation in the upstream, you might want to consider putting a series of if like the PRVs or in series like this, just to give you a more constant downstream pressure. Okay. The one that people.
What you mean by variation is different pressure?
As it fluctuates, because it will, if you have a pressure coming in and that goes up, the pressure coming out from the PRV will go up as well. It then will start to come back down as the spring and the actuator responds to that. But by that time, this is probably dropping off anyway, and it'll go down. So it tends to fluctuate round about the set pressure. You set it at 3 bar, it'll go 3.2, 2.8. It just fluctuates around that. Yeah. Okay. Typically, when you're looking at the parallel installation, or as we call it, a low flow bypass, most people will be familiar with this, where it's an industrial application. I need it to run 24 hours, 7 days a week. So if I've got a problem with the valve and I need to take it out, I've got a bypass there to do that. What it's also good for is where you've got high levels of diversity. So things like hotels, hospitals, or people's homes, etc. Those sorts of things, whereby you know, it's all calculated out for people being in the hotel, say, between 5 of an evening and 7 of an evening. There's a volume of water we'd expect to use based on the number of terminal units within the area. You'll work out the loaded units according to BS 806. Well done. Yeah. And you'll work out the loaded units. You say, yeah, therefore I need this, and at least this size pressure reducer valve. Problem is, someone gets up in the middle of the night about 3 o'clock and decides, I want the toilet, etc. And they go up and they flush the toilet, and that small volume of water is outside of the range of that other valve, and it starts to make a noise. People go, well, it's noisy overnight. What we're going to do? So what you tend to do, you'll use this configuration where those diversity levels are quite high. So and what happens is you set one below. Typically, it depends on your installation, but in this example, it's like roughly about half a bar less. And what happens is the smaller one will take all of that loading up until the demand increases beyond its capability, and you get the higher one. It's sort of like, it's not the other way around. The higher one works until it's low, and the low one will always be fully utilized. Okay, so, and it's really good, things like hotels and that sort of thing. I've been several times up and down to London, sort of on sites, several times. Well, there you go. But yeah, it's really useful for those particular applications. I'm trying to rush now, right? Okay. And with the pilot operated valves you can actually get one where it's built in. So the actual low flow bypass is built in as part of the valve. Okay, I'm not going to go into all the detail. A bit pushed for time. So really from this sort of first part of the presentation, it's really important that, there's a whole variety of pressure reducing valves available on the market, and you really need to select the one to the application that you can consider, whether it's, direct for direct outlets, or whether you feed in a whole series of apartments, or whatever it happens to be. And all I'd say is, like, one does not fit all. You really do need to sort of, which one am I looking for that particular application? Okay, so a little bit of a summary. We've gone through each of those titles there. Hopefully I've explained them I know I'm rushing a bit now, but hopefully I've sort of explained it in quite a bit of detail. Any questions on this part before I very quickly go through pilot operated pressure reducer valves? You okay?
Yeah, go for it.
Right. So again, I'm going to sort of explain a little bit about the general construction, a little bit about setting it, and then finally a little about the installation methods. So as stated earlier, you can get these sort of a standard pressure reducing valve, or you can have it with the bypass built in. And they're just our reference numbers against that. But a whole host of manufacturers offer the same products. It's not.
What type of price difference are you looking at between them two?
Between this one and the previous
Between the
one?
one with the bypass and the one without the bypass?
It really depends on what size you're looking for, because they go right up to, 60.
It doesn't, in this case, it doesn't actually follow a rule of percentage.
Doesn't it?
No, it doesn't.
It's yeah. I'll leave it with him.
We'd have to pick a particular one, to get the price on this one.
Okay, so very simply looking at the construction, where you've got a main body, or like the lower part of the valve is seen there, where the inlet and the outlet is there, and you've got, if you like, an upper body or bonnet or cover over the top, and they're separated by that diaphragm. Okay, now normally the spring wouldn't, the water wouldn't get past the diaphragm. Normally, okay. In the case of a pilot operated one, the top half of the valve, or the bonnet, or the cover, whatever you want to call it, is wetted as well. So the spring is in that environment. And the way the mechanism works is a little bit like, if anyone's familiar, a little bit like a hydraulic cylinder, in that upper chamber, the spring, unlike the other valves where you want to increase the force, you compress the spring down manually. Yeah. In here, it's a fixed spring tension, and how you add pressure to the top of the diaphragm is by increasing the pressure of the water in that upper chamber, and that acts in conjunction with the spring to create that downward force. So it's a little bit like a hydraulic cylinder. So and I'll explain a little bit more about that, and there is a little bit of a video that can get it to work. Okay, well, that's basically how they're constructed. You see the sort of diaphragm separating the two, and the seat and the if you like, that mechanism goes up and down within this whole series of bearings that help that align. So it aligns it to the fixed seat, and it's really the diaphragm relief that moves up and down. Okay. Okay, so it basically works by controlling that pressure within the cover chamber in that top bit. Now, basically, to control that, there are two real control settings that come in. Okay, there's the pilot valve, which is a PRV in its own right, and it's that sets your required downstream pressure that you're looking for. So that's, if you like, the brains of it. It's controlling the pressure in that upper chamber. And then you have a needle valve, which sets the trim, or if you like, or the response speed of that valve. Because what you don't want doing with that needle valve is you don't want it set too far closed that the valve's really slow to react. Consequently, you don't want it fully open, because the valve will start vibrating and banging away quite badly. Has got to be set at site, unfortunately, under the site conditions. If you're in sort of more of your sort of high rise or domestic and sort of environments, quite easy to set. I did one 5 weeks ago now. Yeah, 5 weeks ago now, it only took me 5 minutes. Normally, if you're getting a lot of fluctuations in the upstream pressure, you can be there for hours just trying to get that set right to get the best out of the valve. Okay. As I say, pilot valve is PRV in its own right. And it really is about sort of setting that pressure requirements over a smaller volume of water. That then, because you're doing that, and that's sort of controlling the pressure in the upper chamber, it then means that you can control the downstream pressure on a larger volume of water in the main parts of the body. And as I say, with the needle valve or the trim, whatever you term that goes in there, that's really set for those variations in upstream pressure. Does need to be set at site, and it's all you're really doing is dampening down the effect of those variations upstream within the valve. Yeah, too high, valve sort of loses control and sort of vibrates away. Too low, the valve's not reacting to those variations in pressure. It does need to be set at site. Right, so hopefully, he says.
Expired.
Yeah.
No.
It was, definitely was. I saw the water on the left.
Did it?
Yeah, there you go.
Oh, there we go. There we go. Something's happening. So we always try and say that wherever you fit in a pressure reducing valve, you should have some isolation either side of it. It's good practice. Don't have to. It's just good practice. Okay. So in the way these work, in effect, sort of you open up the isolation, you're opening up the water into that lower part of the body, and you're feeding with that downstream pressure. What you want to be able to do is sort of open the needle valve roughly at the start by about 1.5 to 2 turns. That starts to let the water fill in the chamber. The same with the PRV, and you then set that pressure reducing valve there to roughly giving you where you're looking for that downstream pressure. You then open up the isolation valve. You'll see the PRV pressure will drop. Then it comes back up roughly, and you can then give it that final set point. Dead easy to set. On 2 settings on the valve. Dead easy. You wouldn't believe how many people can't set it. And I mainly put that down to product gets delivered, someone takes it out of the box, installs it, the little manual that's in the box, the little leaflet thing, goes, and then they ring up and well, I'll just set this, mate. Oh, okay. You know, time and time again. But hey,
Spoken to me before, haven't you?
there you go. It's just one of those things, you know. So I mean, we publicise it as much as you can, but still people phone up. So there you go. So yeah, dead easy to set. 2 adjustments, one for the downstream pressure, one that, if you like, sets that speed of response of the valve or the trim. Okay. With regard to installations, ideally, you're going to get the best performance if you install these types of valves horizontally. Yeah, really good. You can push it to 6 inch. I prefer 4, but if you like 6 inch, you can get away with installing them vertically. But to be fair, you never, ever, ever want to put it upside down. Now, I could give you all the lovely bits about debris that could get into the mechanism and trap and stuff. The real reason is purely the whole weight of the mechanism itself, because you're relying on a set spring pressure and then increasing the pressure in that upper chamber. The sheer weight of the mechanism internally will offset that spring pressure, and you'll struggle to set the valve. So it's good practice for the dirt and contamination, but the real reason is about the weight of the mechanism inside. Okay. So they're all the subjects I've run through today, hopefully.
Really?
Okay. If everyone's quite happy, we've sort of covered most of the things there. As I say, I do apologise for rushing quite a bit, but any questions, please feel free.